Good morning, students. Today we're going to take a tour of trinomials and all that you can do with them. This was by request from a fellow student of yours, and I thought this would be useful. It's something that you certainly need to know, and we'll cover some things that aren't actually covered in the textbook. Some things that are more trivia related, but interesting nonetheless. So first of all, let's break this word down. Trinomial. This first part here should give you some indication that we're working with something associated with the number 3. This stem, tri, this prefix means 3, and then nomial we can simplify to mean terms. So when you see the word trinomial or you hear the word trinomial, just think 3 terms. And this is differentiated from, for example, the word binomial. The stem bi means 2, and nomial means terms. So 2 terms. I'll show you examples of each, and then the other one you hear a lot is monomial. Mon means 1, or this stem here would be 1, okay, and then 1 term. I'll show you examples of each. Let's find a new color for this. So here's a trinomial, x squared plus 2x plus 4. A binomial would be x minus 2, like that. And a monomial would look something like 4x. Okay? The key thing here is there's no operator in the monomial. Okay? Look at the monomial. There's no pluses or minuses. Here there's a minus sign, and here there are 2 pluses. So if you actually circle the number of terms in the trinomial, you've got 1 term, 2 term, 3 term. Okay? And then here you've got 1 term, 2 term, binomial. And then monomial, you just have the 1 term. Yes, there are 2 things, but they're being multiplied together. They're considered 1 thing. Okay? So this is the basic nomenclature. This word I just used, nomenclature. This is a word that you see a lot in chemistry, and this just means naming. Okay? How do we name things? So today we're going to be talking about trinomials. So now that we've got a basic understanding of just the vocabulary here, let's dig a little deeper into trinomials themselves and learn more about how they're constructed. Now, the type of trinomials that we're going to talk about in Algebra 1 will mostly be what are called quadratics. Quadratics don't necessarily have to be trinomials, but we're going to be talking about quadratic trinomials in Algebra 1. So let's take a look at a quadratic trinomial. Here's an example. X squared minus 3x plus 7. So again, it's a trinomial because there are 3 terms. Here's the important part. The first term is a squared term. This term right here is called the quadratic term. And it's quadratic because it's squared. Okay? It's a squared term. This term, negative 3x, this is called the linear term. And it's called linear because it doesn't have an exponent that's shown, but we all know that there's really a little hidden exponent of 1. So this is called the linear term. If you isolated 3x out of this problem and graphed it, you would have a graph that passed through the origin and had a slope of 3 over 1. So 1, 2, 3 over 1. That would look something like this. Okay? The quadratic term in isolation, x squared, would look something like this. So again, these are parent function would pass through the origin and would have a mirrored hoop shape like this. So this would be x squared. Okay? Now this final term, this is called the constant term. The reason it's called constant is because it doesn't change. You know, just think about the word constant. That means doesn't change. And the reason we say constant is because if we have a function, if we put this in function notation and wrote f of x equals x squared minus 3x plus 7, and we substituted in, we evaluated this function at, say, f of 1, we would have 1 squared minus 3 times 1 plus 7. You see here that in this evaluation, the x has now changed to a 1. But the 7 did not change. Similarly, if we evaluated the function at f of 2, we'd have 2 squared minus 3 times 2 plus 7. And again, the x would change, okay? But the constant wouldn't change. It would still be 7. And that's why we've always referred to x, y, z, m, n, a, b, all these different letters that we use. We call these variables because they vary. All right? Now there's just one final term that we need to look at before we kind of move on. And that's these numbers that appear sometimes in front of the letters. So here's another example. 3x squared minus 2x plus 4. These two numbers here, so the 3 and the negative 2, these are called coefficients. Okay, these numbers sit in front of letters. And they serve to scale the variable. All right, let me show you what I mean. Let's say I just had x, okay? And let's say x was equal to 2. Okay? Well, now let's say I had 3x. So that would be 3 times 2. So the initial answer was just 2, and the second answer is scaled up 3 times. 2 times 3, which equals 6. Okay? So, you know, you could think of these as scalars in the sense that they scale the variable up, and that can also be negative. You could have negative 3x, which would mean negative 3. In our example, where x equals 2, it would be negative 3 times 2. So that would be negative 6. So you can scale up, and you can scale down. Coefficients can be fractions. Okay? So just be aware of that. It could be 1/2 x, which would mean that if x is 2 and it was 1/2 x, and x is 2, then you'd have 1/2 times 2, which would be 1. Okay, so now we've talked about all these different terms. We've talked about variables, trinomials, binomials, monomials. We're getting to the part where we're going to talk about quadratics. But this is a basic introduction to the nomenclature of trinomials, and I hope this was helpful.